we have two positive integers in this question. I'm going to call them a and b and write that they're greater than 0. An even better way of doing this, by the way, is to say that a and b belong to the set of integers that is positive. We're told that the product, so that's when you times them, is equal to twice the sum, so 2 times a plus b. And we're also told that this is equal to 6 times the difference between the two integers. So I'm going to assume that a is bigger than b, and it's going to be 6a minus b. We typically, when we talk about the difference, we always say that it's going to be positive. Now, we've got these 3 bits of information, and we're asked to find the sum of the two integers. Okay, what to do? Well, we have 2 of them multiplied together. You could try and mess around with that. But like multiplying is a bit more complicated than when you're just adding or subtracting. So I'm going to look at this part first. And if I expand it out, I've got 2a plus 2b is equal to 6a minus 6b. And I can rearrange this to 4a equals 8b, or a is equal to 2b. So I now know that a is twice the amount of b. And if I put it back in, I can get an equation just in terms of a or in terms of b. And in fact, because I have a equals 2b, I'm going to replace a. So it's going to be 2b times b is equal to 2b plus b. I've now put it into the second 2, but you could put it into the first one and the third one. You would get the same answer. So that means that 2b squared is equal to, well, 2b plus b is 3b, so that's going to be 6b. I'm going to divide through by 2. B squared is equal to 3b, and I've got myself a quadratic to solve. B squared minus 3b is equal to 0. I mean, you might be able to see the answer straight away from this, but I'm going to do it like fully. b minus 3 equals 0. B is equal to 0 or 3. Reject the 0 one because we're told that it's positive. So b is 3. Remember, a was twice that, so a is going to be 6, and the sum is going to be 3 plus 6, which is 9.